this class even independently. So both offline and online, right? And leading this time period, we have a diverse experience in digital learning. So hopefully, those who are attending physically as well as online will be enjoyed. So today, basically, we will be exploring the remaining topics. And as I believe, as I remember, I have covered maybe up to this slide. Am I right? Because the last slide, as I remember, right? Okay, fine. Now, I just want to have we said on this particular slide. You can understand many topics in different dimensions. There is not only one dimension to state or to understand a particular topic. If you are now, if you enrich yourself, so we can stay in different groups, in different groups, right? So you see, multiplexing and demultiplexing, right? This term, it has been used in many different subjects, starting from digital logic, right? Digital logic, you have studied multiplexing, demultiplexing, right? In data communication also, in many other subjects also. But why we are using the concept multiplexing and demultiplexing, right? What is the philosophy behind that? Okay, so you see, it's quite interesting. So, process that means we are addressing the transport layer. And in transport layer, you see, it is the convenient protocol for the internet layer, right? So, internet layer ensures end-to-end connectivity, right? End-to-end connectivity and transport layer ensures perfect process of connectivity. Process of connectivity means we sometimes mention some information or the context of information because it's very important, right? End-to-end, link-to-link, process, right? These are the very basics of communications. You see, in your PC, you have multiple processes. Multiple processes means multiple applications, right? For example, in this computer, we are using computer applications. What are those? One is Zoom, another is Microsoft PowerPoint, right? So these are the two different processes. So two different processes, we are interacting at the same time. So it must communicate. Some of your classmates, they are joining online, they are using Zoom, right? Okay. You see, we have many processes, but different processes communicate at the same time to the other end, right? So end-to-end communication, it is established by the IP, Internet Protocol, right? That means two computers are connected. How we can identify the connectivity? You can use another IP layer commands called ICMP command ping, right? By ping, you can connect to different commands. This is the end-to-end connectivity. It works in the IP layer, right? Now you see, you are sending at the same time different information from different processes. But since you are just adding all the information together, right, in the IP layers. But this thing that if you mix up all this information, then the communication will be successful. Never. So you must have some sort of distinguishing feature among the process communication. Right? That's actually the core is addressed. For each and every process, you have some code. Or more specifically, for each and every applications, you must have some code. If you use FTP, you have specific dedicated code. If you use SMTP, you have specific dedicated code. If you use Zoom, you have specific dedicated code for the Zoom. If you use some other ways of doing it, you should have other communication code, right? But behind the IP is same for all the time. So based on the process, you must have the concept of multiplexing.
Hello?
What is multiplexing? It means that you are taking the information from multiple applications, you are merging all the applications by
Hello, sir.
applying some procedure, subjecting this to the multiplexing.
Hello?
And when it is multiplexed,
Hello? Hello, sir. Hello?
yes, just a minute.
স্যার আমরা স্যার মিটে কথা শুনতে পাচ্ছি না স্যার মাইক থেকে একটু দূরে গেলেই স্যার আমরা কথা শুনতে পাচ্ছি না
Okay, can you hear me now?
ইয়েস স্যার
So I am saying very loudly. So wherever I am, you supposed to hear.
স্যার পিসির মাইকটা তো স্যার আসলে ওরকম আপডেটেড না এর জন্য আর কি স্যার শোনা যাচ্ছে না
I have a very good microphone with me. Can you hear me? Yes, it's working because we are just inside the classroom. Okay, so we got the point. So don't worry, we have the recorded session. I am recording for your convenience, and maybe I will be uploading immediately after the class, inshallah. So you can hear right now. The slide is visible to you?
Yes, sir.
Okay, so if you can't hear, just raise your voice. So we are explaining multiplexing and demultiplexing. So this sort of concept is also applicable for the satellite communications, right? Perhaps you are well aware of that. Satellite, it's a very valuable resource, right? And you're supposed to know that in satellite communication, we have a specific time period. And within that specific time period, all the information over Bangladesh that must be multiplexed and sent towards the specific time period, right? So this is a shared. That's why we call time division multiplexing, or sometimes we have the frequency division multiplexing. Why? Because you are multiplexing, you are putting together the part of the information from different applications. That's the thing. Sorry. Now, so you see, this is the slide we are sharing it once again. The first of time, you should have the deep understanding with all the layers. You see here that network layer, we have some protocol that you are already aware of. The ICMP, the ICMP, ARP, RARP. You have heard this name, right? In the transport layer, you have SCTP, TCP, and UDP. And recently, there is another protocol called QUIC by Google, right? These are the 4 different protocols working in the transport layer. Fine. Now you see, over the application, you have different applications. For example, SMTP, simple mail transfer protocol. So if you communicate by using simple mail transfer protocol, you must use, means from the sender side and the receiver side, you must use 2 different port address. In the same time, HTTP file transfer protocol, if you want to transfer file, you should have port address at the both end, receiver and sender. You see the TFTP, trivial file transfer protocol, the DNS domain name system, SNMP, simple network management protocol, and bootstrap protocol. So all the protocol over the application layer, they might run at the same time, but thing is they must have individual port address, okay, and a common IP address. That's the thing. Now, user datagram protocol, we'll be exploring the first one. User datagram protocol. Here are some basic reason of using user datagram protocol. Because you see, we want to make the communication lightweight. We want to make the communication lightweight, always lightweight. That's why in many cases we use user datagram protocol. The basic principle is by using user datagram protocol, what is happening? End-to-end devices are connectionless. These are connectionless. What is meant by connectionless? You should not have the acknowledgement, right? It's just you are transmitting the data and the receiver is receiving, right? So in many cases we use UDP. But do you think that the communication is in failure in most of the time? It's not, right? Most of the time it is successful. But for your, satisfaction, okay, we use registered mail. Why? For your satisfaction. So that you might be aware that the recipient has received your mail. That's why we use the emergency document or important document over registered email or over registered mail service, right? Same thing here. Communication is fine in most of the cases, but sometimes it might be failing. Okay? That's why if you want to ensure that, for example, you are transmitting, for example, healthcare data, right? Nowadays, in wireless 4D area network, the doctors are staying in one part of the world and the patient is another part. You see, you need the real-time communication. It must be very, secure. It must be connection oriented because a single mistake, it might cause a human life, right? So that's why you might have many different reasons. Or if you want to design your own protocol, if you for your own specific applications, at that time you may define which transport protocol you should be using. Fine? That's the thing. But in most of the cases, we use UDP, user datagram protocol, because it is simple and it provides less overhead in communication. Okay. Now you see, the user datagram protocol is called a connectionless, unreliable transport protocol. It does not add anything to the services of IP except to provide process-to-process communications instead of host-to-host communication. IP provide host-to-host communication or end-to-end communication, but it is UDP is adding a value to the IP layer. And what is that value? The value is it is simply providing the opportunity to communicate over process to process. That's the simple value addition by UDP over IP. Is it clear to you? Yes. Okay, let us proceed. So in this topic, we will be covering some well-known ports for UDP. You see user datagram, the checksum, UDP operation, use of UDP. Now you see, in Unix, in most of the cases, we cite the reference of Unix because Unix is the only operating system that has been developed long before, right? And in the basic communication, it was Unix. They developed Unix for the basic communication, right? But the GUI or Windows operating system or other operating system, it comes for later. So you see, in Unix, the well-known ports are stored in a file called etc services. etc service. I think you have some basic, concept of Unix. So in Unix, this is the root, right? This is the root, and under root you have many different directory. etc, right? etc is one directory. So you see slash, that means slash etc then services. It means that under the root directory, you have a subdirectory called etc, right? etc normally called etc. But in Unix, it is not meaning that. It has very specific purpose. What is that? What's that? It is actually holding most of the configuration files. Most of the configuration files. Okay. So etc services. That means under etc root directory, there is etc directory, and you have the services directory. What is the content? There might be a lot of content, but we need not all those content. That's why we are using the command break, right? Perhaps you have some idea of break because it is some sort of searching. Searching based on specific criteria. So dollar grade, you see FTP. You are searching what? FTP. Just only the few entries that are related to file transfer protocol. Why? You see 21 TCP, 21 UDP. So it doesn't have both FTP. Okay, FTP is a file transfer protocol. It is an application layer protocol. So at the time of transmission, it is using either TCP or UDP. Right? You define that whether it is using TCP or UDP. Do we define? No, sorry. Yeah, it is inherent. How it is inherent? It is based on the application. Based on the application. I think now that we have defined during your transmission whether the system will be using UDP or TCP, right? We don't define. But definitely there is a mechanism to choose for which application, right? For example, you see the FTP, it is using both, right? It's using both. So 21 TCP, 21 UDP. So this 21 is the specific port number for the FTP, right? But this port is used both for the source transmission control protocol as well as user datagram. Do you get this point? Okay. Fine. Now, you see, we are exploring another protocol in the application layer. That's the SNMP, Simple Network Management Protocol. It's a quite fantastic protocol. Alhamdulillah, in this trimester, in my university, I am teaching a course that is only exploring SNMP. A master's level course for 3 credit hour course, only exploring the SNMP. Fine? So SNMP is the Simple Network Management Protocol. How you will manage your network, right? That's the only objective of SNMP. So you see, the SNMP, again, it used the port number 161, right? For TCP as well as for UDP. Fine. That means you can also transmit the network monitoring related data over the TCP or UDP based on your own situation. And you see the SNMP track. There is some, command request saying trap, right? So this SNMP trap is another command used for the SNMP services or data communication between between two computers, right? Okay, you see here. So for SNMP, for TCP and UDP, they are using both 161 port number, but for SNMP track, it is using 162. Okay, now you see the user datagram protocol in details. So here you see we have user datagram format. We have 8 bytes of headers. What is the further explanation? You have source port 16 bit, destination port 16 bit. Because port address is always 16 bit, whether it's for TCP or UDP. We have seen, right? Because the last part, we were 65,535 number of ports, where there are some assigned port, unassigned port, future use, many different port, right? Okay, so is the total length 16 bits. Total length 16 bits. And you see the checksum. Checksum is 16 bits. You have any idea of checksum? What is that? How far you have explored the checksum? Error correction, functional correction, right? In which chapter you have covered that? Chapter 9. What's the name of the chapter? Infection correction. Okay, so that concept will be used over here. Why do we use that? Because I told you that in networking we have two different approaches, right? So one is you see the physical and data link, right? Physical and data link. These two layers are sufficient for communication, but the range is important. Over that, you have the application. Application. Okay. For example, please pay me. For example, you are using here FTP, right? Transfer protocol, right? This FTP, if you transmit the file locally, then transport and internet protocol, right? These two, these two protocols are sufficient for local communication. That means communication in a LAN, local area network, right? These two protocols, transport and internet, we use for internet working, right? But the question is, if you don't use internet working, is it important for you? It's not important, right? What is important for local communication? Again, physical. But application is always important because you are not directly using the data link and physical. Rather, all the time you are using application in your purpose. Am I right? Okay. So this application, it can only be used over data link and physical. So data link and physical, these two layers are self-sufficient for the local area network. But if you work in an internet environment, then you have to use the services from transport and IP, right? But the concern is, you see, since it is sufficient in the local environment, right? So in local environment, you will experience all sort of error detection and correction as you experience in the over the because errors might be locally, errors might be international, right? If it is international error in the internet working environment, who will be responsible? This transport layer, right? Because IP protocol is a down, it only connect end-to-end, no nothing for error detection and correction, right? In the same way, physical layer is also down protocol like the internet working protocol. Why? Because this physical, it connects device link to link, that is physically connected. But this physical connection doesn't mean that it will ensure the error-free communication over the physical link. It might be 1 feet distance, it might be 5 feet distance, right? But still, the physical layer doesn't ensure that the communication will be error-free. You understand the philosophy? Right? It's very important also. What you are studying network layer, networking, if you understand these things, you will get a lot of good from it. When in 2009, when I'm doing some research in a very tiny device, sensor network, right? Sensor network, you see, sensor network is very tiny device, and its protocol is also very tiny, right? In sensor network, if you deploy the sensor network in a field, nowadays it's becoming very apparent. But before 15 or 20 years, many people even don't know what is going to happen inside the sensor network, right? But now you are applying anywhere in the field, the agriculture, in the farming, right? In the classroom. So these protocols are using data link and physical. But over the data link and physical, the sensor network should have some application, right? Okay, fine. Now you see that we have divided physical and data link and intellectual and transport. But we will find some components, some process very common. So in data link there, you are exploring the error detection and correction. At the same time, we will be exploring error detection and correction in transport there also. But the difference is one is applicable for local environment, another is applicable for internet world. Fine. That's why we have the concept of checksum. You have the concept of checksum. As you have seen this. So we have any question? So you have seen that simply checksum here, right? Okay, fine. Now, what is the total length? What? What is that 16 bits of total length? Well, if you see like any other header, you have the length. Length of the in IP layer, you have the length of the whole IP datagram. we see total length is the whole length of the header and data at the transport layer. Right? Yes. Okay. Any other question here? You see now, your question is there. UDP length, IP length minus IP header length. Right? This is the UDP length. IP length, that means the IP means we have the IP layer data and header together. Right? And the IP headers length. You will get what? Data. Yes. That you have got from the maybe from the listening here, it's coming from down, right? Or it may come from the up. But ultimately, UDP length is IP length minus IP data. That is, you are discarding IP data part. You will get from the right? Okay. Now, fine. It's a pseudo header for checksum calculation. So I think it's clear to you now. So this actually 32-bit source IP address in the IP header, destination, the other information, and now you see the source port address, destination port address, right? And the data. But you see, data must be added to make the data a multiple of 16 bits. Multiple of 16 bits. That means actually it is representing in 2 bytes. It is representing in forms of 2 bytes. Okay? The padding must be added to make data multiple of 16 bits. Why multiple of 16 bits? Because it is for easier communication. Okay?
You understand what actually this is data.
Right. So you see, you can count in terms of byte, in terms of bit, right? But here, for the sake of simplicity, because we are exploring checksum, checksum will be using the unit as 16 bits or 2 bytes. You understand?
Sir.
Yes.
Sir, important is the network layer. Important is the network layer.
Yes, definitely. It's the IP address, it's the IP address.
In terms of the transport layer. So 8-bit protocol uses the 17 bits.
8-bit protocol, 17. So this two all are how many? This 16 bit, right? This 16 bit is 16 bit, right? All zeros and 16 bit protocol. I'm sorry, 8-bit protocol. So this information is for the transport layer. What transport layer, right? Sometimes you see you have used the sliding window, right? Sliding window, it calculates in terms of byte. It's a byte-oriented protocol, bit-oriented protocol. You see some information, but this is 8-bit protocol, this is byte-oriented. That means it will change the translation based on the number of bytes. Okay?
Also 17.
17, I think this is in bracket. I didn't explore this 17. Okay, maybe the next time.
UDP total.
16 bit UDP total length.
It has a widget and 16 transport layer UDP total.
Just to get used here, most of the information is in terms of 16 bit, right? Even the checks 16 bit. I will show you why we are using 16 bit as a channel. Fine? Just give me a few minutes. Okay, you see here. Figure 23.11 shows the checksum calculation for a very small user datagram with only 7 bytes of data. Only 7 bytes of data. Because the number of bytes of data is odd, padding is added for checksum calculation.
right? Maybe since it is odd, you might make it even, right? Because if you represent as 16 bit, right? So it should be even in number. If it is odd, then some part will be blank. Fine. So you are adding and you are making it even form. Now you see, this is our
Just example of the previous slide. You have seen this header, this is the data, right? You remember? Are you getting the point? Yes. So pseudo header, in the first row we have IP address, second row we have IP address, right? All zeros, 17. This is 15, right? Now this is port 15 and 4. So now 15 was the total length of the data. What 15 was the total length of the data? 15 is the total length of the headers. Header in terms of, sorry, in the previous slides it was only 16. Right? So the length of header. Now this fact that the 16 actually display. Okay, display. It means the value. Yeah, it is the value. Because you see, yes, student. Yeah, it can represent. I mean, okay, fine. So now you see, this is the data part, right? Now we are representing UDP data in terms of 16 bits, right? If it is 16 bits, so you see, UDP represents all the information in terms for the checksum calculation. You see here, 153.1. 153.80.
why we are taking this two part? Because this is the upper most significant bit of the IP address, source IP address, right? Okay, so 153.18 you have represented in binary form.
Totally 16 bits.
Yeah, 16 bit. All the information must be in 16 bit representation we have mentioned, right? So please have a look. It's very interesting.
Final checksum is to be 16 bit. That's why we're dividing all things in 16 bit.
Exactly. So the first, I mean, you see here, this, I mean, IP address 153.1 we have taken in the first row, right? As 16-bit representation. You see 153. If you calculate it in binary form, it will be simply this. Okay, and 18, you know, 1001, and it is 2, right? This one for 16, and this is for 2, which is 18. The lower 16 bit, you see this division, fine, and this is the destination, okay, and you see
First one is the source, second is the destination.
yeah, that's based on the template that you have used. So we have zeros and 17, right? Zeros and 70, because all 0, it means 0. 17, you have UC 15, but one thing is important here. You see, this all zeros and 17 in together it is 16 bit. Fine, but the remaining 15, it is self 16 bit. If you may, it is, there might be a confusion and there may be errors also, right? So if you consider this 15 bit with other, no, it will not happen. So you must look at the format, very specific format, and you will have to add those 15 bits as total 16 bits, right? Then 1086 and even 13 also. Although 13 is, I mean, small number, but you are allocating 16 bit, right? Okay. Yeah, that's 1087 is a port, and 13 is also port, and 15 also total length of the header, and all zeros. Okay. Now you see the data part. Data part is testing. Just simple data. You are sending the testing string.
Taking the ASCII value of this.
Yeah, you are taking for this. I mean ASCII value. Okay, T and E, right? When we'll be assigning you some problem in the exam, we will be providing you the sheet of ASCII code. Okay.
This is the problem.
Yeah, definitely it might be. So we can change the data part,
There is zero
testing or any other things. You will be calculating accordingly. Fine. So this T A E A S N I, these are, and you see the last bit is padding. Why it is padding? Because you are sending testing, but this part is,
rest of the inputs.
yeah. So you must pad by zeros, and it will be 8 bits, 8 zeros, right? So you are summing it up because it is checksum. Okay, the sum. And how you can calculate checksum? It is simply you are applying the concept of ones complement. So if you apply the ones complement to checksum, you see that every bit will be toggled, right? Every bit will be toggled. That means one will be zero, zero will be one.
If there is any carry, if there is any carry, then we have to add it to that sums.
Right, but it's not two's complement; it is one's complement.
So if there is a carry after that sums, so we have to add that carry again with that sums. It was the concept.
You mean this whole, this is a summation, right?
Yes, after summing of all, if it's more than 16 page, so if there is anything,
Yeah, it's a carry.
inside that 16 page, so
Mhm.
we have to take that carry within that sums. Again, we have to sum it up.
That's why you are using the ones complement, right?
Yes.
Yeah, that's okay. So I think now this is clear to all of you, right? Class equilibrium complements. Equilibrium is okay. Fine. Time goes very fast. Fine. So all of you are here from army background, also some of you are from civil also. So you are the same year. If the both from the both of the stakeholders were in the class, then why you conducting online classes?
Some of them they are studying outside, so apart from this schedule, maybe for them is
Based on that,
they some of them they are leading them also. Some of them are leading the enrollment, so they can come by.
yes. So it's for the student those who are staying far away, right?
Yes.
বলো করতেছি
Dear students, those who are joining online, so we have started our second session. So in the second session, we have just simply explained the concept of queue in UDP, and queue means it has a specific time period and time limit, or the length of the queue is specific. We have three defined types of queues. One is bounded capacity, unbounded capacity, and zero capacity. Here, the queue used in UDP definitely it is bounded capacity, not infinite. Now we will be starting the concept of TCP. TCP is a connection-oriented protocol. It creates a virtual connection between two TCPs to send data. In addition, TCP uses flow and error control mechanism at the transport layer. It's quite important that TCP uses flow and error control mechanisms at the transport level. So the topics we'll be discussing here, the TCP services, TCP features, segment, a TCP connection, flow control, and error control. Now you see, TCP is a byte-oriented protocol. TCP is a byte-oriented protocol. That is, the information transmitted by TCP, it counts the number of bytes it is transmitting. Okay, so there is two process, sending process and receiving process, and there is a stream of bytes for the connectivity. You see here, this sort of, transmission of stream of bytes, traditionally it has been represented in terms of these two figures, the sending process and the receiving process, and you have the both sending TCP and receiving TCP whole mechanism. Okay, you see the figure. Next, byte to write. You see, next byte to send, not send, sent. So it is used in terms of the color code, right? The color code, not sent, one color, sent, another color, right? And you have next byte to write another color. So this is just, you see here, the both TCP at the two different computers, it is transmitting the information in terms of segment. That's why we in the IP layer we call the datagram, and in the TCP layer we call the segment, right? The segment 1, segment 2 up to segment n of information is transmitted from the one computer to another computer. Now the byte of data being transferred in each connection are numbered by TCP. So the byte of data being transferred in each connection are numbered by TCP. So why we are calling the each connection, since TCP is a connection-oriented protocol, so in each connection, what are the number of bytes you are transmitting? It is encountered. It is in, it is under monitoring system. So the numbering starts with a randomly generated number. So how the number will appear? Definitely some.
Online আছে তো? না, there is. Thanks. তো all day ঠিক আছে। All day ঠিক আছে। বাটা থেকে ঠিক আছে। বাটা থেকে।
Okay, you see, the numbering starts with a randomly generated number. So randomly generated number means it's not specific that it will start from 1. Just like you are pressing the random button in your keyboard, calculator, right? So every time some specific values are generated, right? So the numbering starts with a randomly generated numbers. You see particular flow of a certain number of segment. The following shows the sequence number for each segment. Okay, you see we have 5 different segments. Segment 1 to 5, but in each segment, how many bytes are transmitted? 5. You see in segment 1, 10,001
to 11,000. Okay, but you see the sequence number starts at 10,001, right? That means range is starting from 10,001 to 11,000, and sequence number you see 10,001 as the sequence number. That means in a particular segment you might transfer multiple number of bytes, right? So it must have some sort of range. But the initial number that we are giving in the range, it is used as a sequence number. So this is the sequence number because you have to keep track that after this sequence, what will be sent. Or if that particular sequence or particular byte is missing or corrupted or lost, you must have to take some sort of recovery detection and recovery mechanism, right? That's why sequence is very important. This sequence is lost, so you can transmit it or you can retransmit it, right? So you have that segment, individual segment, and in individual segment you have multiple bytes in a particular range, and the first value in a range we are calling the sequence number, right? In the TCP header, you have seen the sequence number field, right? Okay. Now, the value in the sequence number field of a segment defines the number of the first data byte contained in that segment that we have just seen. The range and the first number is the sequence number, right? Okay. The value of the acknowledgement field in a segment defines the value of the acknowledgement field in a segment defines the number of next byte a party expect to receive. That is the acknowledgement. You see, dual purpose. One purpose is I am acknowledging that I have received this number of bytes, and the acknowledgement, it has another inherent meaning that next I am expecting to receive from that, right? Sorry. Hello? ওয়ালাইকুম আসসালাম, আপনি কি আসছেন? আপনাকে আমি কল করবো, আপনি তখন একটু কাইন্ডলি আসবেন, ঠিক আছে? আমার সাডেন একটা না একটু ওয়েট করতে হবে, বা আপনি অফিসে যান, আমি আপনাকে কল করব। ওকে, ঠিক আছে, থ্যাঙ্কস লট। সরি। Okay, fine. So the value of the acknowledgement field in a segment defines the number of the next byte a party expect to receive. The acknowledgement number is cumulative. There are few things, which is technical information, please note it. One is the sequence number, right? Another is the range of the particular segment, right? It is random, fine? But the acknowledgement field, right? It defines that next the receiver what by a number of bytes it is expecting to receive, right? But it is cumulative. Cumulative means it is increasing continuously, right? But the sequence number we have seen, it is random. So random, it may not be cumulative, right? Any fashion, any sequence it may arise. But the acknowledgement number is cumulative. Why it is cumulative? Because acknowledgement means that you are sending a sequence of segment, right? So in that sequence, you have received, for example, for first 5 or 3 segment, as right. Next, you supposed to receive segment 4 and 5. So it should be cumulative. Are you getting the point? Okay. Again, please. Okay, so UDP is connectionless, right? That's why it doesn't maintain this sort of sequence. It is this sort of ordering. It is not only maintained, even it is maintained in the IP layer also. Do you remember what's the content of IP layer? If you see the content of the IP layer,
and compute the UDP layer as well as transport layer, you will see a lot of difference, right? So I think the IP, just a minute. Okay, this is here, right? Have you seen this sort of sequence number in UDP? UDP header? No. So it means that it is not following that concept. But the transport layer.
Question also that if there is no sequence number like this provided in that data set, so how will the application there and the UDP get its way? They are maintaining the sequence.
That is, it is extracting information.
So the application itself, after extracting the information, it's then arranging the information. No, it's not happening in the network devices.
No, it's not. It's not happening in the UDP.
Yes.
But you see, in the application layer also, you see OSI layer, it defines application layer in three different application, presentation, and session. Okay, so that part is somehow microcontrolled. Fine, but the UDP layer is not responsible for this. Is it okay? Okay, but TCP layer, it has specifically the sequence number, and it is at 32-bit, right? And the acknowledgement number is also 32-bit, but we haven't seen this sort of thing in the UDP layer. Just let's go back to the UDP. Okay, you don't find anything, right? Only the checksum is there. Fine. Okay, so if you compare all the headers, then okay, fine. So this is TCP segment format. We have the source port 16-bit, destination port 16-bit, right? These are common in UDP and TCP, right? And we have sequence number 32-bit, acknowledgement number 32-bit, acknowledgement number is 16-bit, and sequence number is random, right? Okay. And we have the header length 4 bits, the result 6-bit, and you have some sort of flag. The urgent, acknowledgement, push, reset, synchronization, and finish. It's all the, control information is actually used for the connection created for TCP, right? Okay, then we have another purpose Windows side, right? Windows side is important for the flow control because TCP ensures flow control. Flow and error control, right? So this Windows side, it has another, important applications because you see it's the window, right? Okay, you can control the flow of air, which is so if you can complete your operation, if you get more flow of air, you must stay the operation, you get the faster flow of air. This concept is being used also here at Windows sites. How much we okay, it can. The checksum is also here because it is mandatory. Because of protection, it's a transport layer common criteria. The transport layer will be responsible for any action connection, which is applicable for any step applicable for the CPI. That's 16 bits, and we have source and band. So these are the control field you see. The urgent pointer is valid. Since you see we have urgent pointer 16-bit, the URG, it is actually representing the validity of the urgent pointer field. Acknowledgement field is valid, ACK. The push, request for push, that means for transmission. The reset the connection, synchronize sequence number, and finish means termination of the particular connection. So these are the control field, and these are the further description of the control field. The value of the urgent pointer field is valid. The value of the acknowledgement field is valid. Push the data, reset the connection, synchronize sequence number during connection, and terminate the connections. Now you see, we will see the connection establishment in three-way handshake. Okay, so it's called the handshaking protocol. Okay, so you see the connection establishment in TCP we call the two-way handshake. Two-way handshake, right? Simply just you are introducing a new friend, you are giving some salutation, then you are introducing yourself, and you can exchange the data, right? Suddenly, if you meet someone, you cannot, I mean, translate, okay, please carry this to my friend, right? There must be some sort of handshake. So, it's called a handshake. You have file and server. So, this is active open. That means you are opening the port and you have the sequence number. You see sequence number suddenly you click that. It's a problem of sudden engagement. I had some issues, so I just skip those for because but okay. So you see the sequence number 8000. Sequence number 8000 means it is a random number, right? And you have the different field A and S, right? What is A and S? Acknowledgement and synchronization, right? Okay. So how many fields are here? 6, right? And we have six control fields, right? Out of 6 control fields, you are using only acknowledgement and sequence, right? Why? Because it's the handshake, not for the transmission of data, right? If the transmission of data is there, then push, right? Reset or other things. So you see here the sequence number. This is sequence plus acknowledgement. Okay, so the receiver is sending another segment that contains sequence number 15,000, right? And it was 8,000. So there is no relation between 8,000 and 15,000, right? That is randomly generated. That's the randomly generated number, right? Okay. Now, but this sequence number has one extra information to carry. What is that? You have range of bytes. The first number is used as the sequence number, right? Isn't it? You remember? Okay. Just I'm addressing this slide. This one, right? Yes. You have 5 different segments, and in each segment there is a range of bytes, right? The first number it is used as the sequence number, right? And this sequence number is randomly generated, right? Okay. Now you see.
So from the sequence numbers, how can we understand the length of the sequence?
How can you understand?
That is the first byte of the length.
Mm-hmm.
So how can we understand the length of the sequence from the sequence number? It's only stating that the first byte is 8,000. If it's a 1,000 feet long sequence, how do you understand?
Yeah, actually, you see, this is only the handshake rule. We are not transmitting data. So when the data will be transmitted, then there are some
other properties.
Yeah, right. So it is for the handshaking, fine. So it is sending the sync and it is sending the sync plus acknowledgement. Why it is sync plus acknowledgement? Because you see the acknowledgement field is 8001, right? Your sequence number was 8,000, right? Sequence number 8,000. Now you have embed the acknowledgement as 8,001. It means that you have received 8,000, right? So, and this new sequence of 15,000, fine, and you see it's sending the sequence number 8,000 once again, but it is acknowledging 15,001. That means you have received these bytes. Okay, so after that's actually the connection established. Now, it will be the process of time it will transmit that. Right? So handshaking it has 3 different ways. One is sync plus acknowledgement and acknowledgement. That has been established. Now you can transmit it.
So it is quite interesting, but it is also you need to go through the textbook also, line by line. Please. For this few, sections, I told you the last part also. You must go through it if you want to have the deep understanding. Right? This one? Okay. So this is QA handshake. The scribe has initiated as sync message, and this is the format of the sync message. The sequence number random generated number, right? The acknowledgement will be zero because it's not for acknowledgement, and you have saved the particular control bit, right? Okay. So this is the acknowledging this, sequence because the acknowledgement is 8001, right? And the sequence number is different. These two are not the same in sequence because it's only the handshaking protocol and it's randomly generated number. And finally, you see the client acknowledges that, okay, the sequence number, you see the acknowledgement of 15001, that is this, the server has received this method, acknowledged, and the client is again acknowledging that, yes, I have received your acknowledgement. Now, the connection is established between the sender and receiver. The sequence number, it should be because it is this sequence number is from the client. It is used for 2 times. Why? Because it is only for the handshake purpose. And this sequence we actually don't have any problem. In connection to 8,000. Actually, this is very number. In connection to for this particular example. For this particular example, and it is random number. So random number can never be this. So is there any way that we can predict this? Computers, is there any ways you can see these headers, the model of the headers? The only thing is the packages in this no, if you use Wireshark, by using Wireshark, you can see everything, you can visualize. Okay. And I for good understanding, you need to use the Wireshark tools. You just I use Wireshark reports, but I didn't understand those things. That kind of when I understand. So maybe I understand. Yeah, so you see here. Why we are explaining this? This is the content of Wireshark, right? If you send this information in the Wireshark, you will see the same thing, right?
Nowadays, zeros and ones start.
Yeah, that definitely. So everything has, levels of understanding. So you go further, you'll see. We are studying this book maybe for last 25 years. All the time we are reading, we are getting new information. So it's a continuous process. If you go for masters, you will go for PhD. If you are in communication, you will have to go through this thing time to time repeatedly. Sometimes you forget because it is very difficult to remember each and every point, right? Okay, so a sync segment cannot carry data, but it consumes one sequence number. A sync plus acknowledgement segment cannot carry data, but does consume one sequence number. And finally, an acknowledgement, if carrying no data, consumes no sequence number. Okay, you see, the three-way handshake, after three-way handshaking protocol, you only can transfer data. And this is the data transmission. Are you getting the point? We are proceeding very slowly. Just now we have finished the handshaking, three-way handshaking. Now after handshaking is successful, then you are transmitting data. So please, would you please explore this slide for the data transmission? Just explore, have a look on the slide and try to understand how the data are being transmitted. Okay, I think I missed one point. It is not in the slide. By the time, DDoS setup, right?
Yes, denial of service.
Yeah, denial of service setup. It is related to this figure. It is related to this figure. Remember it and note it. Maybe you may ask me, sorry, this was not in the slide, but it is in the text. We're not only following the slide, we are also following the sequence of the text, right? So in the text, it mentioned the denial of service attack. What is denial of service attack? And it's very important because nowadays people means you are really interested in cybersecurity and other things, right? So you see, this is simply the connection establishment, right? So for example, the connection establishment is unknown from unknowns, right? If thousands or millions of buyers like this, what will happen? Given the surrounding workforce. You see, the client is sending. I experienced this problem in my own life. Okay? When I was administering some server in VDN, we are using VDN too, right? I was in charge, CTO of VDN too for 2 years, from 2008 and 9. Since I was in charge of the VDN, headquarters, so we used to check the log files. Okay, every day we did a server, it experienced millions of attacks. Why? You see, nowadays we can easily understand there is bot, right? It's bot. Here is a bot, it's repeatedly sending you the connection request. So if your server will Namaste, right? I have request that.